Good afternoon, professors from UT Austin. My name is Mark Lane, and here I'll be presenting the PIG Flashlight Reengineering Project for the Engineer Your World program at my high school, John Paul II. In this project, our team learned how to analyze an existing product and the consumer's needs for it in order to design a new and better product. Let's get started. Alright, so the first part of this project is figuring out what our customers' needs are for this flashlight and what information we can draw from those needs so that we can develop new design specifications to meet them. We first received the flashlight and were encouraged to give our thoughts on it after analyzing it. We are also grouped up into teams of 4. Now in this group, our consensus was basically that the flashlight was a cheap novelty trinket with a decent flashlight. We were surprised how decent the flashlight actually was, considering that it came in a very cheap packaging and the actual flashlight felt pretty low quality in our hands. On the other hand, however, the hand crank definitely had the most reactions. Half of our group thought it was annoying, but the other half thought it was part of the novelty. I, for one, thought it was annoying, but our own thoughts weren't so much important as were the thoughts of the surveyors, which would act as our consumers. So, next up was jotting down the design specifications, quantifiable and qualitative data for the original flashlight. On the screen is a basic overview of the PIG's features and dimensions. It measures 4 inches long, 2 inches wide, 1.5 inches tall, with a 4-inch cord at the back to wrap around the wrist for grip. There was also 2 3/4-inch sliders, one to power on the light, and one to lock the rotating mechanism for the inside. We also measured the light intensity of the bulbs, which were 1,250 lux, and we also measured the sound of the ratcheting system, which was 72 decibels. And that is actually slightly higher than the average human conversation, so it's a bit loud, and that's why many people thought it would be annoying. It was these elements that the survey participants would judge to see what can be improved in the final product. Now, these very survey participants acting as the consumers, these consumers have customer needs. Satisfied customers means more profit from a business standpoint. So not only must the needs be met, but also be met and implemented well. This will make it more likely for a third-party manufacturer to actually build our final product. It should come as no surprise that for the flashlight, the actual light is the most important consumer need. For a specific flashlight, the needs that the customers found lacking in our specific example and survey were that the strap size was too small, the crank lever sound was much too loud, and the physical appearance was lacking. Now, why would you ask physical appearance? Well, usually the aesthetics of a flashlight are second hand to the functionality, but since a large part of what makes our specific PIG flashlight special is the aesthetic design of it being a pig. So the appearance takes on more importance in this scenario. It's also important to consider the competition. For a similar price, a customer could instead purchase a much better light for $5 at a gas station, such as the example shown here. This example actually was made out of higher quality materials and had a much stronger light compared to our PIG flashlight, so it's always important to keep the competition in mind when making a new consumer product. Now, we conducted our survey as mentioned before. Our teacher instructed us to go around the school and pick 4 individuals, as we did, and they were given a series of questions to answer, considering criteria for the PIG, which the criteria was flashlight feeling in the hand, the crank, the light, the practicality of the flashlight, and strap, as well as the appearance. The results were that there was 1 minor complaint over the size. There was half the participants thought that the noise was annoying. All participants thought that the light was at least adequate. And 3 of the 4 participants said that the strap was much too small, and also 3 said that the appearance could be improved. So far, we have studied the PIG and surveyed potential customers for their needs, but now we begin changing the design specifications so that they would correspond to the customer needs. For example, if the customer needs a longer rope, aka the cord, the design specifications for that rope must increase to meet their needs. The new specifications must also have reasonable ranges as well. The manufacturer cannot just go off the rails with exceedingly expensive materials and sizes. On the screen here on the left are the user needs corresponding to the improved design specifications chart. So, the user needs that needed changing were a longer rope, the improved appearance, the noise being changed, and also the lights. For example, if the customer thought the noise was too loud, which some did, which affected their user experience, we could change that design specification in our future model by, say, changing the different materials inside the PIG. So next up is the functional model section, and this is where we begin to go inside the design process. This consists of a system of actions and functions coming together to make the whole product work. It helps discover needs, realize processes inside the system, and help identify opportunities via an abstracted functional chart. Starting off, we have the black box method. So this is before we've actually opened up the flashlight proper, and we can only guess what really makes it tick on the inside. In a black box, the left side is the human input, so say me flicking on the light switch. On the inside is the function, which is the actual making of the light inside the pig. And the output of that function is the light energy, so the actual light beam coming out. So we did this for 6 different things, including but not limited to the cord itself, how it makes the light, the gear function on the inside, and this is all, remember, before we've actually looked inside the pig. So before we've looked inside the pig itself, we have some functional models which basically outlines all of the functions of the pig from beginning to end on how it makes the light. So in this example, in the first one, we started from cranking the mechanism, to the generator, to the battery, which powers the light. And all of these have corresponding energies. So human energy goes into powering the crank, which turns into electrical energy, kinetic energy, which turns into electrical energy at the end. And we made a revised one as well to accompany, but all before we actually opened the pig. Now bear in mind, these will be partially incorrect due to that very reason. Before and after diagrams were also drawn. So before we opened the pig, we were encouraged to think about what the inside would actually look like. So I believe that there would be a crank powering a large gear here, all connected by a ratchet arm, which would directly power a generator connected to the lights. Then we actually unscrewed the pig and opened it up, and we could see that the inside, we compare the true interior against our predicted sketch. So the inside, it wasn't too far off, however, the ratchet arm was in a different location, and we did not consider the possibility of there being a large magnet, which there was, and that acted as part of the generator system powering the lights. Alright, so we opened up the flashlight, and now we can make our final function model, which we base the rest of our design process on. This includes every function of the powering of the light from beginning to end: the crank, gear wheel, magnet and coil, wire, light bulb, and lens, with each corresponding energy component. Now it's important to also consider in energies such as heat and noise. An overheating battery is dangerous and could result in a potentially very costly recall for a manufacturer. Reduced noise was a customer need as well, so it must be heated. Now this functional model is the backbone of our design process. From here on out, we refer to it. It is the abstraction of our individual goals we want to achieve with our new flashlight. And so back really quick, this is our dissected photograph, and so we base the functional model off these images right here. Next up is the brainstorming and mind mapping phase, still based on the functional model. Brainstorming, any idea is fair play. The most reasonable ones are the ones that we actually wrote down in our notebooks after heavy discussion. So for example, we have some pretty solid ideas here, such as changing the material to bioplastic or simply changing the cord length. For the light, we could try different brands, and for the aesthetics, we tried several fun little ideas. Once we got our best ideas from brainstorming, we organized them into a mind map, which basically keeps our brainstorming process nice and tidy. It's also important to consider the prices, so the main reason most of our brainstorming ideas didn't get put in place is the price. It's important to consider that some things can stay the same. Learning from our over-engineering of our previous pinhole camera, we decided not to go crazy over every detail, overcomplicating the products. In terms of money, any manufacturer will tell you that the designing of a completely new product from scratch is vastly more expensive, so it's still okay to keep some things from the old design. If it isn't broke, don't fix it. Now we're approaching the final sketch. We have the cube chart, which is assigning a numeric input of importance from the team towards each criteria. For instance, I think the light is important. I add a +1, a numeric input. And it kind of helps us prioritize what we need to change. And finally, we have an early technical sketch on the bottom here, which is towards the end of the design process. So nothing is finalized yet, and we've reached the end here. Final proposed design. So what's new in our redesign? Well, we needed to address every need from the customer. If all their complaints of the original design were eradicated, what is there to stop them from buying our new products? So it's vital to include every new aspect fulfilling their customer needs. For example, the cord length, they needed to change that. We increased it to 5 inches so it could accommodate more wrists. Materials changed to soft touch bioplastic, which would deaden sound, as would the new brushed metal gear. And also little sneakers added for a more fun appearance. And that last one created a huge response from our engineering class. Every teen wanted a pig now. With products like these, it's often the silliest changes that can provoke the most demand. And the final technical drawing can show the measurements, which did remain the same according to the original pig since there was no complaints. And we changed the materials inside, which would hopefully lower the sound from the original 72 decibels. So here we addressed, you can see, all of the user complaints to create a new product that will hopefully satisfy all of their demands. So we have reached the end. We have covered how to analyze the products and the customer needs, a functional model, and finally creating the final design.